to record. Okay, so I'm just gonna leave it on the board. It's not useful when I forgot to record, and he got cut out too. So let me, just for the recording for the people who aren't here, and who keep getting knocked out, I'll just go over this briefly. So this is our triangle for the problem. We set up with these different variables, R, X, and then the question asks us about how rapidly X is changing. So that would be dx dt. And we are given that the guy's pulling the rope in at a rate of 2 meters per second. I made it negative because R is getting smaller, right? So, but in this problem, it doesn't actually make much of a difference because both things are getting smaller. So, but just for, you know, accuracy, because R is getting smaller, we're going to make it minus, and that was this, and then we take the derivative. So we have Pythagorean theorem, we take a derivative, both X and R are changing with respect to T, so you get this, you solve for dx dt. We already know dr dt and R because they told us. We have to find X at the time when R is 5. So it's pretty straightforwardly a 3, 4, 5 right triangle. So X is 4, and then in the end we get the 5/2 meters per second. Because this guy's negative, that guy's negative. Again, and that makes sense because X is also getting smaller. So that is the way it is for problem 4. And he just can't stay in here. All right, I'm going to try. Hopefully that works now. People are getting knocked out all the time. Anyhow, so any questions on that, you guys? All right, so we went through it fairly detailed when it was not being recorded. Sorry about that. But anyway, it's on the board now. So other questions on other problems? All right, now we have Adam in twice. Okay. All right, so did anybody try any of the other problems? No?
I did number 1.
Yeah, okay, so number 1, again, it's just, they get long, but it's pretty much just using the rules. So if you can do chain rule, you can do number 1. Does anyone want me to go through one of those? No? All right. Number 2, again, number 2 is a little bit long, but it's not terrible. You have to do, can you just not do that right now? Sorry, guys. We can, basically you're given the distance and you have to find velocity, acceleration, and all those things. So I guess we can go over number 2. So number 2, the thing you have to remember is just you have to take, you have to use the product rule, right? So the velocity is going to be 2t e to the minus t minus t squared e to the minus t, right? And then the acceleration, I have to take the derivative again, product rule both times. So I have 2 e to the minus t minus 2t e to the minus t minus t squared. I'm sorry, 2t e to the minus t minus and minus with plus, right? So t squared e to the minus t. that's my acceleration. Right, so when is the particle, wait, actually, so I did A and E there all together, whatever. So the particle is at rest means velocity is 0, right? And if I group it like that, it might be a little bit nicer. And then, so I solve this, e to the minus t is never 0. So I end up with t times 2 minus t minus 2, whatever, equals 0. So obviously we have t equals 0 and t equals 2. Okay? So when is the particle moving in the positive and negative direction? We have to look at the sign chart for v, right? Because when the velocity is negative, we're moving in the negative direction. When the velocity is positive, we're moving in the positive direction. Obviously, it'll be found to change the signs at 0 and 2. So if I do a sign chart, I can see, all right, if I put in 1, then I'm going to have something positive. If I put in 3, I'm going to have something negative. So that's my sign chart. So I can certainly say that it's moving forward. Yeah, moving forward. T goes from 0 to 2. And backward for t greater than 2. So if I draw what's going on with this, if this is S, I'm starting from 0 as time t equals 0. I'm starting from 0. So t equals 0. So S is going to move. Do I want it? You know what? I don't know what I want to do. Like, here's S. So it's going to move until t equals 2. It's going to move like this, and then it's going to move backwards, right? So I want to think about it that way. So if we find the total distance traveled, we have to consider the distance it travels in the first 2 seconds, right? And then we have to add it to the distance traveled in the next 4 seconds. So S of 2 minus S of 0 plus S of 6 minus S of 2 is what we want. So now we're putting our numbers in here. So this is going to be 4 e to the minus 2 minus 0 plus 36 e to the minus 6 minus 4 e to the minus 2. Right, and then whatever number that is going to be your total distance that it travels. And then speeding up and slowing down is, I guess, the last question here. That would be asking about the sign of the acceleration. So are we okay with this total distance thing? Because I know sometimes that can be confusing. All right. I'm going to take nothing as okay, fine. So we know we got that. So I can erase this. So if I look at the acceleration, okay, and let's ask where that's 0, because then we'll do a sign chart for the acceleration. So wait, this is the velocity, right? So my acceleration, if I set this equals, Okay. T squared minus 4t plus 2. 2 and 1, 2, I don't know. Let's see. Did I have that right? Okay, so maybe it doesn't work out. So, t is minus brain fart, b squared a 16 minus 4ac8 over 2a. So I end up with 4 plus or minus square root of 8 over 2, 2 plus or minus root 2, right? So both of those are in there, right? In my so starting with 0, this would be 2 minus root 2, and this would be 2 plus root 2. And so if this is going to be plus, minus, and plus. Yes, yes. Okay. So it's initially speeding up, and then it's slowing down, and then it's speeding up. Okay. So that would be that. Okay, you guys, do you have other questions about this? 3 is fairly straightforward. You just use the population, like population at time t is p naught e to the kt, and you kind of have to do it 3 times, right? Yeah, 3 times you have to do that, because the k will be different for the different numbers. And then for e, e is just sort of think about why the exponential population model is a simple model and what could go wrong with that. So this is sort of like a conceptual question. Yeah, see something in the chat here. Okay. Okay, good. Yes, all right. Any other questions? No, we're good on the. All right, then, if nobody has any other questions, I will see you guys next week, or if you want to stop by office hours on Friday. All righty. Bye. Have a good weekend.